Hey ladies and gentlemen, this is Ms. Humbert here, and we're going to be doing Unit 5, Notes 4. So today we're going to be talking about parallel lines, proportional parts. So we're going to take what we've learned about proportional parts up to this point, and we're going to start applying it to some parallel lines. So let's go ahead and let's take a look at what that will look like. So for this first part, if a line is parallel to one side of a triangle and intersects the other two sides, and then it divides a segment into segments of proportional lengths. So let's kind of draw out what that means. So I'm going to label this triangle. I'm going to label the triangle itself A, C, and then D. And I'm going to have a line cutting through it. And that line is going to be EB. So let's write out mathematically what all this mumbo jumbo means. So what it's saying, if we know that that line that's cutting through the triangle, BE, is parallel to the bottom, CD, then we know that if we take AB over BC, that proportion has to be equal to AE over ED. So we're really setting up a scale factor like we've done before. Okay, so we're setting that up. So let's take a look at this and apply it to an example. So in triangle PQR, ST is parallel to RQ. So then we know the parts have to be proportional. It gives us that PT is 7.5. It gives us that TQ is 3, and it gives us that SR is 2.5, and then that gives us X. So now what we want to do is we want to set up our proportions. Okay, so what we're going to do is one fraction is going to have things that are on the same side. So I'm going to have 7.5 over 3. So each fraction contains things that are the same side. Then on the tops, I want to have the upper part. Since this is upper part, I want to have the upper part of the other side. And then on the bottom of that fraction is again on the same side. So now remember, to solve these we use something called cross multiplication. So we're going to take and we're going to cross multiply. So 3 times x is 3x. 7.5 times 2.5 is 18.75. So next, that 3 is being multiplied by the x. So we're going to take and we're going to divide both sides by 3. And then we get that x is equal to 6.25. So x is equal to 6.25. All right, let's take a look at the converse of this. So we're going to take what we did in that previous theorem and we're going to flip it around. Okay, if a line intersects two sides of a triangle that separates the sides proportional segments, then the line has to be parallel. So basically we're saying if it's proportional, then it also has to be parallel. So it works in reverse. So let's set up that triangle like we did before. We had A, C, D, and then we had the line EB cutting through it. So now let's set up our proportional sides. So we're going to have same side over same side. Now since DE is on the bottom, then BC needs to go over the top over here. And then we're going to have AB on the bottom. Okay, so if those two are proportional, if their proportions are equal to each other, then we can actually say that EB, that line, is going to be parallel to DC. So as long as we can show that they're proportional, then we can say that they're parallel. So let's take a look at this problem. In number 2, it asks us if triangle DEF, so EH we're given is 3, HF we're given is 9, and DG is the 1/3 the length of EF. Or GF, sorry. So we're going to let GF represent X. And we know that DG is 1/3 the length of that. So DG is 1/3 X. So now we're going to set up our proportions. So let's set up this side first. So we're going to put same side over same side. Then that 3 is on the top. So that means 1/3 X needs to go on the top of our other fraction. And that X needs to go on the bottom. So now we're ready to solve using cross multiplication. So we're going to take 3 times x and 9 times 1/3 x. So 3 times x is 3x. 9 times 1/3 is just going to give us 3 and then x. Well, we had 3x is equal to 3x, which is the same as 3 is equal to 3. So are the proportions equal? Yes. So yes, that means we have parallel lines because our proportions are equal to each other. What we found was a true statement. Now let's take a look at this idea of a mid-segment. The mid-segment of a triangle is a segment with endpoints that are midpoints of two sides of the triangle. Every triangle has 3 mid-segments. So that's kind of confusing, okay? So let's take a look at this. So what it's saying is this has a midpoint. And so that means that this side is going to be the same. This length is the same as this length. Likewise, this side has a midpoint, and this length has to be the same as this length. And that's just by definition of a midpoint. Likewise, this side has a midpoint, and this side has a midpoint, and this side has to be congruent to this side. So now let's connect our midpoints. Boop, boop, boop. So we're making a little triangle within our triangle. Now here's the cool thing about the midpoints, is that they're parallel to the opposite side. So for example, this side has to be parallel with this mid-segment that's sitting opposite it. Likewise, this guy right here has to be parallel with this. Now remember, we do parallel saying parallel with the number of arrows, okay? So that side's parallel to that side. Likewise, this side right here has to be parallel to this side right here. So that's just a property of the midpoints, and we'll use that as we get further on. Okay, let's take a look at the triangle mid-segment theorem. The mid-segment of a triangle is parallel to one side of the triangle. That's what we just showed. Okay, if we connect two midpoints, it's going to be parallel to one of the sides. And the length is 1/2 the length of that side. So let's kind of take an experiment of what that means. Let's put this midpoint here, and we'll call it J. Let's do this midpoint here, and we're going to call it K. Let's call this point F, and let's call this point G. Now, what do we know about a midsegment? Well, we know that if it's a midsegment, that's equal to that, and that is equal to that. Okay, that's what we know so far. So what does this theorem tell us? So it tells us that if J and K are indeed midsegments, then JK is parallel to FG. Okay, we know that from the previous page. Now here's the new part. And we also know that this line right here, this is the new part, so I'm going to write it in a different color. This is the most important part. That this line right here, JK, so the length of JK is going to be equal to 1/2 the length of this FG. So JK is equal to 1/2 the length of FG. Next, let's take a look at this. Number 3. In the figure, XY and XZ are the midsegments of RST. Find each measure. So let's start by calculating out XZ. So I notice that XZ connects two midpoints. So that means that this line is parallel to this line. I also know that this length right here has to be half the length of the side that it's parallel to. So XZ is going to be equal to 13 divided by 2, or 13 times 1/2, and that's 6.5. So that's that length. Now let's take a look at ST. So ST is this side here. I notice that ST is parallel to this guy right here. Now, I know that let's do it this way. So we know that XY is 7. So XY is equal to 7. Well, I notice that this is connecting two mid-segments, and it's parallel to that line. So that means in order to get ST, since this is on the outside of our triangle, we need to take 2 times the length of that mid-segment in order to get the length of ST. So ST is going to be equal to 14. Alright, next, let's take a look. We want to find the measure of RYX, this angle right here. Well, here's one thing I know. I know that RT, this guy right here, is parallel to XZ, and that's because they're connecting the two mid-segments. So I know that these two lines are parallel. Now here I have a transversal coming down. So let's think about what we know about parallel lines. We're trying to find this angle right here. So what I noticed is that this angle and 124 are on the inside of a transversal. Likewise, not only are they on the inside of a transversal, but they're on inside of the parallel lines. Sorry, they're on the inside of the parallel lines, opposite sides of the transversal. That makes them alternate interior angles. So this guy right here has to be equal because they're alternate interior angles. So that's 124 degrees. Alright, let's take a look at number 4. So it's given that IJ is the midsegment of FGH. Okay, so this right here is a midsegment. So we need to find x and y. So first of all, that makes J the midpoint of this line FH. Since J is the midpoint, that means that these two sides have to be congruent but to each other by definition of a midpoint. So then we know that 2x plus 5 has to be equal to 5x minus 7. So now we're going to solve this for x. So we're going to subtract 2x from both sides, and then we get 5 is equal to 3x minus 7. Add 7 to both sides, and we get that 12 is equal to 3x. And then since that 3 is being multiplied by the x, we're going to divide both sides by 3, and we get that x is equal to 4. So x and 4 are the same thing. We're done with that one. Next, let's take a look at this one. So we know that this right here connects two midsegments. So that means that this line right here needs to be parallel to this line right here. And also by that triangle midsegment theorem, we know that this is 1/2 the length of this. So this length here is 1/2 the length of that one. So we're going to take 1/2 times that length. And that's, 6. That's how we're going to get our y. So first thing I'm going to do is distribute in that 1/2. So 5y plus 1 is equal to 1/2 times 8, which is 4y, 1/2 times 6, which is 3. So now I need to get my y's on the same side. Since this is a positive 4y, I'm going to subtract 4y to both sides. Then I get y plus 1 is equal to 3. Subtract 1 from both sides, and then I get that y is equal to 2. So here we get x is equal to 4 and y is equal to 2. Last but not least, let's take a look at this part right here. So I'm just going to erase this so we can see it a little bit better. So if the measure of angle F is 50 degrees, the measure of angle H is 30 degrees, find the measure of angle JIF. Okay, so what we have here is this is parallel to this. Here we have a transversal cutting through. This angle right here and this angle right here are both on the upper left corner of the transversal. So that makes them corresponding angles. So that guy right there is also 30. So to get this angle, we're just going to take 180 minus 50 minus 30. So that gives us that the measure of that angle is 100 degrees. Since this is 30, we just use that to find the angle because we have a triangle formed right there. Last but not least, let's take a look at this one. Find the values of A and B. Okay, well, if this is parallel to this, that means that this represents the midpoint, even though it doesn't look like it. So that means these two sides are equal. So if this is 7, this sure as shoot better be 7. So what's 7 plus 7? 14. So that means A has to be 14. Remember in geometry, we can't just go off of things based on looks. Okay, so now we know that this is a mid-segment and this is the side of the triangle. So we know that this is 1/2 the length of that. So 8 is equal to 1/2 B. We can also look at that as 8 is equal to B divided by 2. Well, how do we get that 2 over the other side? Well, we multiply both sides by 2. So we get B is equal to 16. So B is equal to 16 and A is equal to 14. So that concludes your note video today. Go ahead and show me a completed note sheet when you're done. Thanks for listening.